Hello everyone and welcome to Tutor Terrific. Today I'm going to be deriving the quadratic formula for you, which you see here. And this is commonly used in Algebra 2 courses, Algebra 1 courses, and Math 2 courses if you're in integrated math. The first time you see this is probably the most menacing equation you've ever seen in algebra. And it's used to solve quadratic equations of this form. ax squared plus bx plus c equals 0. X squared is the first term and a is the coefficient of that term. X to the first power term is next and b is the coefficient of that term, and c represents some constant number. Now the formula you might have memorized or been asked to memorize with a song. The song is negative b plus or minus the square root of b squared minus 4ac all over 2a. You might have recognized that song. We are going to derive this formula today. Now, it comes from the completing the square mechanism, okay? Now, here is an example of something where you'd need to complete the square. Why would you need to complete the square? Because you can't factor this. I cannot find two numbers that multiply to negative 7 and add to 4 that are integers. And so we are going to have to do this another way. And that's where completing the square comes from. It is the backbone of the derivation we are going to do of the quadratic formula. So I want to make sure you understand how to complete the square. The first step is to move the constant term, which doesn't work for you, to the other side. So we would add 7 to both sides, and it would look like this. X squared plus 4x. Now I'm going to leave a space, and I'm going to write the 7 on the other side. So now it's positive 7 on the other side. Then what I'm going to do is I'm going to complete this square. Here's how it's done. I'm divide the middle coefficient of the x to the first power term by 2. That would equal 2. And then I square it. 2 squared. And what is that? That's also 4. And so I'm going to add that in that space. Now, whatever you do to one side of an equation, as you know by now, you must also do to the other side. And so we will add 4 to the other side as well. So now we have x squared plus 4x plus 4 equals 11. On this side, we can factor based on how I created this quadratic equation, this quadratic expression, also known as a trinomial because it has 3 terms. What we will do is we will see that this factors into 2x plus 2's. So we can write 1x plus 2 squared. It's called a perfect square trinomial. In other words, the middle coefficient divided by 2, you can add that to x, put that in parentheses, and square it as a shortcut to factoring this side. The other side is just a single number, 11. The next step is to square root both sides, because remember, we're solving for x. And so we will square root both sides, like so. And always, when you square root a number in this fashion, when you're solving a quadratic equation, you must add a plus or minus to the side with the number. So the next step is to remove the square and the square root on the left, which cancel each other out. And we get x plus 2 equals plus or minus root 11. And this is exactly why I couldn't factor this side, because it's very hard to see irrational numbers like square root of 11. The last thing you have to do is just subtract 2 to both sides. And so you have x alone. X equals negative 2 plus or minus square root 11. So this is completing the square. And now we will use that to derive the quadratic formula. We are going to start with the quadratic equation, which looks like this. Like you saw before, ax squared plus bx plus c equals 0. I have to set up the completion of the square by first subtracting this c, the constant term, and moving it to the other side. So now I have ax squared plus bx, I will leave a space, equals negative c. What you noticed in the example problem I did for completing the square is that the first term coefficient of the x squared was 1. We want that when we complete the square. The only way to do that generally is to divide everything by a. And so I'm going to divide all the terms by a. Obviously those two cancel, and so now you have x squared plus b over a x space equals negative c over a. Now we are ready on the left-hand side to complete the square. Like we did before, we will take the middle coefficient, b over a, and divide it by 2. Well, what is b over a divided by 2? It is b over 2 times a. Those are equivalent. And then we are told to square it. Okay? So we are going to add this to both sides. I'm going to apply the 2 power to all the terms inside, and I'm going to get b squared over 4a squared. I'm going to add that, as I'm supposed to both sides. What you do to one side of an equation, you have to do to the other. So here we have the square completed. This will factor, just like all completing the square trinomials will factor, into 2 binomials. Binomial means 2 terms of a factor. The first part will be x plus half of the middle term, or the middle term divided by 2. b over 2a squared. So that's what this factors to. And over here, you just have these 2 fractions. Negative c over a plus b squared over 4a squared. Now, we want to start working on the right side because it's messy. First thing that's messy about it is that these fractions cannot be added together in their form because they do not have the same denominator. We need a common denominator. A and 4a squared, what is the least common multiple of those two? Meaning the smallest number that is a multiple of both of these terms. Here's how you determine that in general. The least common multiple will have 1 copy of each common factor and 1 copy of each unique factor. So the least common multiple, LCM for short, is going to have an a, which each of these 2 denominators have, and then it's going to have 1 copy of each unique factor. The 4 is unique to just this denominator, and another a is also unique to this denominator. The other one has no unique factors. All those together, if you multiply the a's together, give you 4a squared. 4a squared is the denominator we want. Now that's just the same as the denominator of the second fraction. It just happened to work out that way. So now we're going to rewrite this. Right-hand side. It's 1 fraction now with the least common multiple, often when we're doing fractions called the least common denominator, downstairs. On top, we have the first fraction, which was missing the 2 unique factors of 4 and a. So we have to multiply the top by 4a. You get negative 4ac. The second fraction's numerator does not need to be multiplied by anything because it already has the entire denominator from the least common multiple. So we'll just add the b squared. Now it's customary in algebra for us to reorder these terms so that the first term is positive. It looks a little cleaner. So again, I'm going to copy the left side. I'm going to write the top fraction's numerator with the terms reordered. So we get b squared minus 4ac. That looks familiar to me. I hope it does to you. And we're going to work with that. Okay? The next step is to square root both sides because we have fully factored the left side. Just like we do in completing the square. And so I'm going to move to this column over here. When I square root this thing that is squared, all I get is the thing inside. X plus b over 2a. On the other side, I can split this square root into 2 square roots, one of the top and the square root of the bottom. That is equivalent to what you see right now. B squared minus 4ac over the square root of 4a squared. Those are equivalent, and that is nice because if you look at the denominator, I can perfectly square root this without any irrational numbers. Well, what is the square root of 4a squared? First, let me copy everything else. B squared minus 4ac. The square root of 4 is 2. And the square root of a squared is just a. So the square root of 4a squared is 2a. This is starting to look very familiar. We're almost done. The last step, oh, pardon me, I almost forgot something. When we square root numbers, we have to include a plus or a minus. So this side should have a plus or a minus from now on. The next step is to get the x alone. So we're going to subtract b over 2a to both sides. I'm going to choose to put it first on the right side for reasons that will become clear in a moment. So over here it cancels. On this side, now we just have the x by itself. I'll start by writing the term I just subtracted over there, negative b over 2a, plus or minus everything else that I have over there. Square root of b squared minus 4ac all over 2a. Now notice that we have two fractions. It's always nicer to write it as one fraction, but these denominators are already the same. And so we can now combine these fractions without having to find the least common denominator. It's already there. So we have just one giant fraction over 2a, negative b, and then plus or minus the square root of b squared minus 4ac. We have just derived the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, and we have finished. Until next time, this is Falconator signing out.